Hello, and today we're going to have a look at how to work out the area, an estimate for the area under a curve using the Trapezium Rule. So if you decide to study maths at a higher level, we will use another method which is called integration, and that is a lot more accurate because it takes into account the curvature of the line. So if you think about like a quadratic, so for instance here we've got a negative quadratic, and a trapezium can't take into account that at curve. And here we've got a positive quadratic, so basically again the trapezium is overestimating the area when it goes down. When it goes back up, it actually underestimates it, as we can see from the other one. So again, that's quite actually a common question in an exam. If we use the trapezium rule, will it be an overestimate or an underestimate? So basically, if you just have a look at those two graphs, you can quite clearly see which is the under and which is the overestimate of the area. So we are using the area of trapeziums, which are superimposed onto a curve, to estimate the area under a curve. So we basically use the area of the trapezium, and a formula for the area of the trapezium is a half a plus b times height. And of course a and b are the two parallel sides of different lengths, and h is the distance between the two parallel sides. Okay, so basically if we use the trapezium rule, we're normally told how many strips to use. And this might be like part B of a big question if you've got a negative quadratic or a quadratic and they say find the area under the curve between such and such in the x-axis. So in this case what I've got is I've got the formula of the curve, or the equation of the curve, and it's given as minus x bracket x minus 4. Okay, so basically this is our negative quadratic in this case, and the two roots are 0 and 4. Okay, so what we need to do is we need to come up with how long each one of these strips are using the 4 strips. So this one here would be 1 across, this one here would be 2, and then this one here would be your 3 across. Because we're using 4 strips, each one has to be 1 across. So basically, if we're to draw our triangle in, so area of triangle A, so what we've got here is we start off here and then we go up here. In fact, it would probably be better to draw a straight line. So we go here and then we go up to there. So you can quite clearly see that this is actually an underestimate. Okay, so between 0 and 1, the distance between that is 1, so that's like your base. And what now we've got to do is we've got to work out the height, which is this line here. And we can quite simply do that by working out what y is, the y coordinate. So the y coordinate here, all you do quite simply is substitute your x coordinate in, which is 1, into this formula. So what it becomes is minus 1 bracket 1 minus 4. So basically that equals 3. So minus 1 times minus 3, which is 3. So this one here is 3 up. So let's just write this there. So that one there's 3. Next, what now we've got to do is we've got to move on to our trapezium B. So trapezium B would be from this point here to this point here, and you can quite clearly see that this is like your top, this is your bottom, and then this bit here, the distance between the two, is your height. So what we've got here is what we're trying to do is we're going to work out what our height is here. And our height here is we've got to substitute our x coordinate, which is 2, into our y coordinate finder, which is this. So it's minus 2 times 2 minus 4. So that means basically it's minus 2 times minus 2, which is 4 here. Okay. So what now we've got is our area of trapezium. And our area of the trapezium quite simply is a half and then 3 plus 4 times by the height of the trapezium, which is 1, which is 3.5. Now the next trapezium is exactly the same because basically it's a symmetrical thing. So here, if we carry this line on, it should be pretty much perfect. Yeah, perfect. So we just got to draw that there, like so. Okay, so basically our next trapezium here is this one here. So what you've got is 4 as this length here, or as this height here, 3 as this height here. But again, yeah, you can check it against the y coordinate. So basically we know that the x is 3, so it's there, and we're trying to work out the height, and then we substitute your x coordinate into this formula here, which again equals 3. And then quite simply we just substitute the values into your formula, and then we get the area of D, and D again is just a triangle of, so the base of this is 1 between 3 and 4, and the height of this is 3, so it's a half times 1 times 3, which is 1.5, and then quite simply you just add them all together. Okay, so thank you very much for listening today, and we hope that you found finding the area of the curve, or an estimate of the area under a curve, and it helps you in your studies. Thank you very much. Cheers. Bye-bye. Bye.